Right. Now we are trying to solve this particular equation using bisection method. And remember, this equation may have so many roots, right? Yet we are trying to find out a root which lies in between only 2 and 3, right? So one thing you are given. And secondly, you see, you are given the equation as x log x base 10 is equals to what you call 1.2. But usually while solving any problem in bisection method, we try to take it as some function is equals to 0 on the right side, right? It should be something like f of x is equals to 0 always, right? So to get a form of this way, I'm just rewriting the equation like this. You see, let x into log x base 10 is equals to 1, sorry, let me take this as f of x. Let f of x is equals to, I'm taking it like this. You see, x log x base 10 is minus 1.2 is equals to 0. Now see, this is my function f of x, and you are given the exact root lies between 2, 3, right? But we don't know certainly whether the function value is negative at 2 or it is negative at 3. So just to calculate where we'll get negative function value and where we'll get positive function value, I'm just trying to evaluate the function values at 2 as well as at 3. Right. See, to proceed further, we need to create this function in our calculator. You see, I'm just erasing everything initially. Then see what I'm trying to do here. We need to create a function, to create a function. There are two logarithmic functions, now this time we have a log function in our calculator, in our function, in our equation. See, here we have two buttons, look at them. One is LOG and the other one is LN. When it is LOG, understand it is a logarithmic function with base 10. When it is LN, understand it is a natural logarithmic function, log function with base E, right? So keeping that in mind, if you recall the function, you see what you have. It is x log x base 10. So I'm just entering, you see here, just above this closed bracket button, you find an x. To get that x, as I told you, we need to click on this alpha. Click on this alpha and then closed bracket button. So click on this alpha and then this closed bracket button. You will get, you see, x on the screen. Then we need to use log button, log x base 10. So I need to use LOG button, log. Again, you need to take x and close this bracket. Now we see we got x log x base 10. Now minus 1.2. Right? There it is. Now see, here it is a calc button. When you click on this calc, it will ask you the value of x. The interval what you are given is 2, 3. You see, first I'm entering the value 2. Just you click on 2 and click on then equality button. So this is the function value at 2. See, it is negative, minus 0.5979. Next, again click on then this calc button. Now, when you click on this calc button, it will again ask you the value of x. Then now we enter the value of x as 3 and then click on this equality button. Right, then you see it gave you a positive value 0.2313. Right, like this, by creating a function in your calculator, we need to use this kind of operations. Okay, how much we got for f of 2?
Minus 0.5979.
So we got this as negative. And how much it is?
136.
2313. Let me take, I'm interested in taking only 4 digits. Right, see, we got one value as negative and other one as positive, so that as you are given in the question, you can see what you call this function has a root in between what you call 2 and 3. Now see, since we are proceeding in bisection method, we need to choose our next approximation. In fact, you can take it as first approximation initially. The first approximation it is normally we take it as x1. It is equal to, it is the middle point of this interval 2, 3. So as we know, it is 2.5. Now let us calculate the function value at this point x1. Some of you, how much it is? C. Substitute x is equals to 2.5 in the function.
Minus 0.20514.
Good. So we got it as negative. Fine. So then see how much it is. I'm just taking a diagram to avoid confusion here. Before getting x1, you see the interval is this 2, 3. As we observed already, at 2, the function value was negative, and at 3, it is, it was positive. Now at the middle point 2.5, see, we got again here also the function value as what you call negative, right? As we know, always there will be a root where the function values are of opposite signs, right? See, there will be a root in an interval where the function values at the end points are of opposite signs. See, if you look at 2 and 2.5, at these 2 points, the function values are of same sign. Both are negative. But at 2.5 and 3, as you see here, see the function values are of opposite signs. Therefore, after this, you can say the root lies between 2.5 and 3. Right? Now, see, we get a new interval, right? Now, let me take the second approximation. Let me just write it directly. Second approximation of x2 is equals to, it is again the middle point of this. So 2.5 plus 3 divided by 2. So which is equals to, as you know, 2.75. Now let me calculate the function value at this value 2.75. I got this as 0.00816, which is anyway positive. Right? I'm interested in this only, whether it is positive or negative. Since this is positive, I'm just taking a diagram again. See, it's better to take diagrams to avoid confusion, especially in bisection method. So before getting x2, the interval is this 2.5 and 3. At 2.5, we got the negative function value, and at 3, it was positive. Now at the middle point 2.75, we got this as also positive. So now keeping this diagram in view, can you expect what will be our next interval? The root now lies between, anybody?
0.5 and 2.7.
Good. So see where the function values are of opposite signs. Because the function values are of opposite signs at these 2 points, you can find a root between these two, 2.5 and 2.75. Right? So now let us calculate the third approximation, x3. x3 is equals to, again, as you know, it is the middle point of these two, 2.5 and 2.75 divided by 2. Right? See, let's see. When I calculate the average value here, I got it as 2.625. And when I calculate the function value at this new approximation, third approximation, I got it as negative. Now then see, keeping that negative value in view, I'm just taking a diagram again. So I'm taking the diagram to avoid only confusion for nothing else. Now see, this is for x3, right? Before getting x3, the interval is, you see, 2.5 and 2.75. So if I take only those values here, one is 2.5 and the other one is 2.75. As we know, 2.5, at 2.5, the function value was negative, and at 2.75, it was actually positive. And now at the middle point, 2.625, we got this as also negative. Now see, looking at this, we can see at 2.625 and 2.75, since the function values are of opposite signs, therefore we can say the root lies between now 2.625 and 2.75. Right? Now see, from here, let us now calculate the fourth approximation. X4 is equals to, it is the average of these two values, 2.625 and 2.75 by 2. So this is equals to, I'll just do it quickly, 2.625 and 2.75 by 2, it is
2.6875. Right, then if you calculate the function value at this fourth approximation, 2.6875, I've substituted here, you see. So I got it as minus 0.046 anyway, which is negative here. Since this is negative, we can then choose the next interval by taking a small diagram of this kind. Before getting x4, see the interval is this 2.625 and here it is 2.75. Now we got a new point in the middle, which is 2.6875. Let's see at 2.65, it was a negative function value and here it is a positive function value, and at 2.6875, again we got this as negative function value. So therefore, you can say now the root lies between, see, the function values. So keeping that in mind, you see, I'm writing this as my next interval 2.6875, comma 2.75. Fine. Now see, if you calculate the fifth approximation, again, it is the average of these two. You see, I'm writing it directly, 2.6875 plus 2.75 by 2, which is 2. Look at this carefully, 71875 I got actually. But still, I'm just rounding off this at fourth digit. So instead of 71875, I'm just taking this as 7188. If some of you are interested, you can even continue with 875. Okay. So this is 2.718. I'm rounding off it to the next integer at the fourth place. Then if I calculate the function value at x5, you see, this is equals to, I'm just calculating this, 2.7188. Now see, I got this as negative this time, minus 0.0190. So since this is negative, again, see, I'm taking a diagram to select the next interval. See, here it is 2.6875 and this is 2.75, and at this we'll get negative function value, and here it is positive function value, and at the middle point that it is 2.7188 also we got the negative function value. Now keeping this diagram in mind, you see, you can just tell me the next interval what it is. The root now lies between 2.7188 and 2.75. All right. Now see, I'm just continuing this further to calculate the next approximation. Therefore, x6 is equals to, one point you see we are forgetting. After getting x5 here, you see, after getting x5, if you compare x5 with x4, see, not even one digit is same, right? That means you have not even reached one decimal accuracy. So now I'm calculating what you call this x7, I mean x6, and then let us also compare this. See, when I calculate x6, it is the average of these two numbers, and see, I got it as 2.7344. Now see, if you now compare what you call x6 and x5, yes, one digit after the decimal point is same, which means at the end of x6, we got what you call one decimal accuracy, right? So since we got one decimal accuracy, we can proceed further easily. We can try till we get what you call 3 decimal accuracy, right? So I'm just calculating the function value at this x6. Function value at x6. Cals 2.7344. See, I'm getting it like this, minus 0.0054, which is anyway negative. Since it is negative, right? See, when I got function value as negative at x6, I've just done, I've taken this diagram, you see. So when I compare these values again, the next interval is 2.7344 and 2.75. After getting this next interval, you see, you can now calculate what you call x7. So the next approximation x7, as we know, you can calculate it by this 2.7344 and 2.75. right? That's how you see I got x7 as 2.7422. Now, if you calculate the function value at this approximation, seventh approximation, f of x7. So this is 2 point how much? 7422. See, I got it as positive this time, 0.001355. Now see, when you compare x7 and x6, still we have only one, what you call one decimal accuracy. So we are continuing further. Now, because you got now x7 as function value at x7 as positive, I'm just taking this diagram again to choose the what you call the next interval. So before getting x7, see, this is the interval 2.7344. Let's see what I've done. After getting this f of x7 as positive, I've just drawn this diagram and I've observed the function values at these 3 points. Because the function values are of opposite signs at these 2 points, the next interval is this one. And then again, to get the next approximation, I've taken the average of these 2 values. I mean the middle point of this interval. So it is x8, 8th approximation. Now again, I'm calculating the function value at x8. So f of x8 is equals to, if I use my calculator to calculate this, 2.7383. See, we got it as minus 0.00204, which is anyway negative. Now see, because this is negative, I'm just taking it again. Before getting x8, see the interval is this 2.7422, and the other one is 2. Sorry, this is 7344. And here it is 2.7422. And now the middle point is this, you see, 2.7383. So if you look at their function values, at the middle point now we got this as what you call negative only. Now therefore you see, if you look at this carefully, the next, the actual root lies in the next interval as this 7383, comma 2.7422. Right? See, even after getting x8, if you compare it with x7, still we have only 1 decimal accuracy. So we're expecting at least a 3 decimal accuracy, because we have already reached x9. So I'm just continuing it like this. You see, I'm taking the average of these two, 7383. And see here, I got the next approximation. Let us say it is x9 is equals to 2.740. Actually, I have 0.025 here, but I'm rounding off this at 4th digit. So I'm taking it as 0.3. So then if I calculate the function value at x9, you can see how much it is, 2.7403. So I'm getting this as minus 0.30301, which is negative, you see. I got now the function value as negative here, so that you can see. I'm just taking a diagram here to calculate, to check the next interval. Now see, before getting x9, if you look at the interval, it is 2.7344, oh sorry, 2.7383 and 2.7422. Now the middle point, what you got here is 2.7403. And at this 2.7403, we got the function value as negative. So therefore, now the root lies between 2.7403 and 2.7422. Fine. Now, therefore, if you calculate the next approximation, x10, so it is the average of these two values, 2.7403. And see, I'm getting it as 2.74125 is there. So I'm taking it as 2.7413. See, after getting x10, I'm just comparing this with x9. See, x9, it is 2.7403. And here in x10, it is 2.7413. So now I got 2 decimal accuracy at x10. So I'm just continuing it further to get what you call at least 3 decimal accuracy. So x10 calculation f of x10, you see 2.7413. So this function value is now positive to 0.3057, which is positive. So I'm just taking this diagram. Before getting x10, you see the interval is this 2.7403 and 2.7422. And now the middle point is this 2.7413. And we got this as absolutely positive, so that the next interval, the root now belongs to this interval 2.7403 and 2.7413. Now see if you calculate the average of these two, the 11th approximation, it is 2.7403 plus this. See, I got it as 2.7408. Now you see, after getting this x11, compare this x11 with x10, right? When you compare those two, you see you have not yet reached what you call 3 decimal accuracy. So I'm just calculating one more step, I guess, because we are going to take the middle point of the next two intervals, next two values. So it certainly will get what you call this 3 decimal accuracy. Let me just continue for one more iteration. So let me first calculate the function value at x11, which is at 2.707408. 2.7408. Right, see, it is 0.00013, which I got it as positive. So therefore, if I take the next interval before getting x11, see, this is the interval 2.7403 and 2.7413. Right, see here the function value was negative and here it was positive, and at the middle point here 2.7408. So we got this as the positive function value. So therefore, now the root lies between 2.7403 and 2.7408. Therefore, the next approximation x12 is, see, it is the middle point, 2.7403 and 2.7408. Certainly it will be in that, I'm sure. Yes. So it is 2.74055 is there, but I'm taking it as 06. Now, because of that, as you can see, if you compare now x11 and x12, exactly 3 digits are same in 2 successive approximations. So therefore, we can say we have reached what you call 3 decimal accuracy, right? Since we have reached 3 decimal accuracy, so therefore we got 3 decimal accuracy. Since we got 3 decimal accuracy, we can say we can stop the problem here, and therefore the approximate root is, see, whatever you got at the end. So that is the approximate root finally, 2.7406. Right? So that's how you can solve this problem using bisection method.